change the title because the title I think is in Objective C, which yeah, which is not what we want. So today we are making pagination on our relational database in Racket. Okay, so let me put this aside and let's go. So let me act first talk to you about what we did last time. So last time we made a file called b+3 Racket,
Yeah. Then
which
we do
was
the FFI.
probably one of the easiest times ever.
Yeah, that
So
seems pretty easy.
so this does exactly
Mm-hmm.
this is kind of the same thing as your test, and stuff like that. So this is how you do it. So you basically put the signature of what the heck is the C type signature,
Mm-hmm.
and then you put the path of the file and so on and so forth, and it worked fine. And then we started doing we made a file called pagination, which
Mm-hmm.
has the structs that we're gonna use to model the records that you have here. So you have something called a page, which is instance. It has a field called instances, byte array, and then we already made the guards. So every single time you try to create a page, the guards will check if what you're passing to those fields, indices, indexes, they are a vector of bytes, and the indexes needs to be a
Tuple.
vector of tuples. So this is how you do it. So vector const of two.
Oh, it doesn't need to be integers, by the way.
What? Sorry.
It could be like a random object.
Okay.
In bracket, precisely, it's actually easier to do that than in F sharp.
Okay. And then there was also a thing that you made the name pagination. Uh,
Yeah,
I
so
was not very
okay.
cool.
Let me go over the entire structure first,
Yeah,
and then
but just
we
one
see
second. I
what to do.
just changed the name of pagination to a pager because pagination doesn't is not a good name in my opinion to a struct.
Um, I'm fine with that. I
And
do
we
have the
discovered that this
case
is a
to do
thing.
that. But C pointer.
Yeah, so this is checking if tree, which is the second thing of the struct, is actually a C pointer. These are the type of things that are so cool that Racket has. Like it's so easy to just apparently do FFI like with C. They have built-in
Yeah.
stuff. Crazy.
Do it in Okamo is impossible. It's really insane. You have to
Anyway,
make like special bindings. You have to import stuff on C. Like it's
hmm
really bad. But
okay.
anyway,
So this is what
so
we had so far. So now I want to go through these. So what is the first function out of this pipeline?
so let me actually share from my side because I want to point to stuff.
Sure.
Uh, disk. I even forgot where I put this file. Is this? Yes. Can you see?
1 second. Yes, I can see.
All right. So basically, the goal of this part here, uh, it's the read, right?
Yeah.
Um, so the write, we don't care. We're closed on that. We
Yeah.
might still revisit it to make a few changes, but this is all the scope of the read, just to make it clear.
Yeah. So as far as I
So
can tell, our goal is to do a search. So this is basically
yes.
like give me
So
some
let's
data.
start. So mine is not finished, by the way, but I will highlight what I think should be changed or whatever it's still unfinished. So let's start from an approach of let's go top to bottom. I think that'll make things substantially easier. So
Okay.
we have a search function here, and the search. Let me, if I can increase. The search is basically just a generic entry point that we're gonna call from the executor as of now. We're not, remember, we don't have a commit, we don't have like wall files,
That's
we
true.
don't have any of those. So it's
That's true.
just like a random function where we just spit stuff, right? We just call. So what this function is concerned with is it picks a schema, it picks an entity name. So I want to do a
Yeah. Yeah.
search
Yeah.
based on this table.
That makes
So
sense.
for now, we're not doing joins, we're not doing anything, right? It's just
That's
one
gonna be
table.
crazy.
Yes. Uh, and then basically what we're doing here is that we pick some parameter for projection. Okay.
Yeah.
If you recall in the relational model, a projection is the select and
Yes.
the select is the where.
I have a question.
Go on.
Can I see whatever is an expression dot projection parameter?
Yes, sir, you can. Can I jump on here? Thank you.
Yes, yes, you can see the things on the
No, I
device.
can't because GitHub
No,
doesn't
open the
understand.
thing there, the arrows. Well,
Wait, here?
yeah.
I don't think the point. No, it's not on this directory. That's why
Oh, okay.
it's on language. Because this comes from the lexer and the parser. So I think it's in here, maybe.
So what is a projection parameter, I guess?
So for now, it's basically just all or a restriction, right?
That
So
makes
the star,
sense.
literally star, or a list of things I want to get out of it.
Okay, so
So
for now it's basically gonna be kind of like a. Oh, but the restrict actually carries a string, right?
a list of
A
strings.
list of strings, yes.
And why?
So
These are the columns I want to bring about, right? I want to project these columns. So this is the pi operation on relational theory.
yeah, okay. We can go back
Relational
to the
algebra,
other file
sorry.
now, and now I understand completely what we are doing.
So, and then on the key, and then you need to pass something by which you will be searching, right? Which is a key name, so the column, and the key you want to search by. Right now, it's just equality, and so I'm just assuming it's like equality.
Wait, but
So
you
that's it.
said that the key name is the column. Can you elaborate on that? What does that mean?
So there, like you would have a column that will be indexed,
Okay, so you
right?
want to search the column by the column name and the key not
Yes,
done.
like ID, name, and age. Like ID would be probably the primary key, right? In that
Yeah,
case,
yeah,
so that will be already indexed.
yes.
So that's it.
And the
If you want to
key is
search
the
by the
actually
name,
and the key is actually the value.
the key is the value by which you are comparing. As I said, it's just a equality comparison. So it's as if you're doing a search like select blah blah blah, like select all from a table where ID equals this ID. You see?
Oh, okay. So you're assuming it is all the key name is always going to be ID, and
Yes.
the value that you are doing the. I see.
So, man, this is like very grug because I'm just using equality, right?
But it
Ideally, I
seems
would have
like
to
the
pass.
best initial implementation. Makes sense.
No, yes, but well, we need to do better than this, right?
No,
If
of
we're gonna
course, but
research.
as a
Um,
first step, I think you made a great choice.
but okay, so and then we try to find the relation. So if we get it, we get the physical count of it. This is our role ID, by the way, which is basically just telling us what is the amount of entities that we have in code as of now, right? We
Yes,
store that
yes,
information on the schema and
we do
on
have
the
that.
alongside the.
We do have that.
Okay, and then we have the description of this relation, right? The rows, the columns it has, and all the types, right?
Mhm.
And then what we do is that we should be iterating. I'm not doing that, by the way, but I will go back. I'll go deep, and then I'll come back. Okay. So I basically call this build pagination, and then with this build pagination, all that I'm doing is setting up a lot of stuff. So I get the relation size, I divide the instance size by the amount of this magic number here is a page size. It's 8 KB, so like 800 bytes, right?
Mhm.
8,000, sorry, 8,000 bytes. And then all that I do is that I open a read on the file with that name that I know will be here. And then I do a seek pointing on the beginning. Then I say, okay, I can only have 64 pages at maximum in the memory loaded at the same time.
Okay.
So this would be like some kind of global variable, whatever, that we would control, right, to basically not overflow memory, like to control our memory.
Yeah, basically. Yeah.
So this would probably like it would probably we would just like have to look at the OS and see how much memory is available and just do a project. That's on the statistics module, which is another thing the databases that we are not gonna do.
Statistics model.
Yes, it's a thing that predicts how much it will take to run this, what are the resources it will need to allocate. Man, this is extremely complex. I
Okay,
like
so
it.
we are
Yeah.
shaving bits at that point.
Yes, because it will be basically like, oh man, like I planned like this table here is this, and it's doing kind of this query.
Yeah.
Okay, I expect this query to take like this amount of memory. So do I have that free? Because otherwise, there's no point on you to start doing it, right?
Mhm. Mhm.
So that kind of thing is the what goes there. And then I build the pages. Okay,
Yes.
so let's think of what is a page, right? I think that will help.
I think it's a
A
chunk, as a chunk.
It's a chunk of what you have in your disk because the
I think it's
point of a
actually
page,
searchable chunk. I think that's more accurate.
yeah, the point of a chunk, the point of a page is for you to read parts of your code that you have on not your code, sorry,
That you
parts
have
of a
stored.
file that you have stored
Yeah.
without loading all the file. If you have like
Exactly.
1 petabyte stored on disk in one single file,
Yeah.
probably wouldn't want to go that far. But anyway, imagine you do have
Are we
something
gonna do
very heavy.
like if I ask for all the entities with ID 1, oh 1,000, is are we gonna like swap the pages, like go to page, searching for it?
I didn't understand. Can you say it
Yeah,
again?
because exactly what you said. You have a petabyte of data. Let's
Mm-hmm.
suppose that the data that I'm actually asking for is the one at the last page.
Right.
So you're gonna have to do, if you're not doing any sort of clever mechanism, you're gonna use brute force, which means that going from page to page.
Yes.
So that's
It's
that's
a
kind of
serial
interesting.
search, right? It's a serial search.
Exactly,
The
that's
way
a
you said.
serial search.
So that would go in the beginning because you don't know, right? You don't know where that would be. So even if you found, by the way, in that search, even if you found something that is on that pin, like in the middle, you would still have to go to the end to be aware, depending on the query you gave, because you don't know if there is another record
Of
that,
course, if
like,
I
if it's a
ask for the
primary
first
key.
one, you can short circuit, but
Yes, exactly. But if it's a primary key, you can prune the search, right? You can stop searching
yeah, of course, that
because you
makes
can
sense.
guarantee that you're not gonna have a duplicate. But
Oh
if
well,
it's
we
something like
care.
a
Let's make that explicit. We care that the primary key should be unique and stuff like that. We care
yeah,
about that.
no, I mean I don't see the point of it not being. That's why I called it not even primary key. I called ontological key because that's the essential thing that gives meaning to the role.
Yeah, I
In my
understand what
design.
you're saying, Maget, but we need to remember that people
Yeah,
use
yeah, yeah.
relational databases to all sorts
To
of
store
crazy
JSON.
things.
Yes. But
I
not
was
to
not
do the
going to
relational.
that, but that's a perfect instance.
Yes. Okay. So uh, to do post normalization on indexing in JSON. So um, okay. So what this build pages does, right? I basically build an array with like buffer with a buffer here
Mhm.
that I'm initializing, which is mutable by the way, and that is
Yes.
because of this read. It
Yes.
has to pass a mutable thing to it.
Mhm.
Uh, and then all that I do is that I jump from page to page with the amount of instances I can pick from this page. Okay?
Mhm.
So I can only load 64 pages, right? And
Yes.
then I'm jumping for these instances per page. So this is the amount of instances I can have loaded at once in one page. And I'd err on the side of caution here because I do a integer division, right? So if it can host like 3 and one would be chopped, I put like 2. You see, I
Yes.
leave one, which is fragmentation essentially.
Yeah. Yeah. Yeah.
Um,
So you basically need
one
to do a
form of
sealing
it.
every time.
Yes, I'm just filling the pages. Yes,
Yes.
I'm just filling the data for the pages. Right?
Yes.
So okay, so what I do here in the end is, oh, I just noticed something. I'm not cleaning this. so I might read trash at some point.
What do you mean by you're not cleaning?
Because if I'm reading less than this size here,
Yes.
then the previous iteration might have read and it will still have the stuff there. So depending on the behavior of this function, for it to be cleaning this thing before I committed to it, which I don't think it is doing.
Wait, I am
So
confused. You said something really weird. So line 113, you have a mutable buffer. If you have read less than 8
let's say I have
kilobytes,
like 4 slots, right? And
yeah,
then the first passage I read all the 4, and then I like all of them have like now new bytes, right?
sure.
It has one integer, let's say. Um, and then the next iteration that I do, uh, I read just 2. Let's suppose it's an int16 instead.
Mm-hmm.
It will still read as an int64 because there are still 2 bytes that I left there. I don't know if it cleans. You see, I would need to flush the thing before.
Oh, you mean at each iteration of the loop?
I would need to clean the buffer, I think. Well, I don't know. I don't not having a problem with that, but so maybe this function, this
No, no,
read,
but you're
either
talking
reads
about
it
doing a
all.
flush at the end of each iteration of the loop?
Yes,
Oh,
because
okay.
either, but I think that's not necessary. Maybe because maybe the read already either cleans the buffer or it reads to that amount. Like so I'm not reading chopped. If there's a case where I read less than I expect, then maybe that could happen. But
Okay,
anyway, that's
okay.
a concern of my implementation, so who cares?
No, we care
Okay,
because at the beginning we're gonna try to follow your implementation and try to improve along the way. So that's a good catch that you did there.
so anyway, we have the amount to read, which is basically a calculation based on the instances per page that you can
Instance
have,
size, that makes
the
sense.
size of each one of these instances. If it's greater, if this multiplication here is greater than what you have on the reader, that means what you have to read is still less the amount already read, which it starts as, which is controlled by the thing inside, by the higher level function.
Uh,
Then, if that is the case, then I do, okay, I can only read what I have left. If I can still read more, I read the entire multiplication of the instances per page times the instance size.
oh, you're basically checking that if you have left in the page, if
Yes.
that is
So
enough
if I
to
have
like.
exactly, if I have like space for more than what I already have on the disk, like let's suppose I can load 10 entities at once, and I have like 2 in the disk. I'm not
Yes.
gonna attempt to read more than what I
Yes, you're
have in the
gonna only
disk, but
read
I will
two.
do, yeah.
But if you have 11 in the disk and your math is saying to,
I'll
to
read
read 10,
10,
you're gonna read 10.
I'll read 10 and then leave one for another page. Yes.
Yes, yes, yes. So this is basically the chop chop.
Mm-hmm.
Okay.
And then
Uh,
I update the amount already read, right, to keep track
what
of
the
what
heck
I
is this
what I'm reading.
construct? Is this a computation expression?
This thing here.
Yeah, this entire for loop.
Oh no, this is just like Python.
Oh,
Like this is a what's the name of this? It is actually a computation expression because I can yield. You see?
yeah.
So
Okay.
lists in sequences uh, and arrays in F# are computation expressions as well, like themselves.
Okay. Okay, so let's
Uh,
go on. So what
okay,
is
and then
happening in line 121? This is mutation. That's what is
yeah,
happening.
I'm just updating right with the amount I really had
Yeah.
plus the amount that I read just now that I will
Yeah.
read actually,
Yeah, yeah, yeah.
and then I read, and then I get the instances, and then a page is composed basically of an array. And by the way, why is it an array of arrays of byte, right? It is like this because I want to separate the elements physically. Uh, like I want to logically, not physically, sorry. I want to logically separate what is physically joined in the disk. So if I have 10 entities, I want to know where one entity starts and where one entity
Yeah, you
ends.
could just have a byte array, but then you're gonna have to do
Yeah, but
another chop chop
that'll
later.
be a hassle. Yeah, that'll be a hassle to handle. So I think to just go by the index number.
Yeah.
So what I would have is just like a slot containing all this row in there. And then all that I do is basically this. I load everything by size with this instance size.
Yeah.
And then what I do is that I take what I can on this page bound. So if I read like more than 64, which is what I gave here, then more than what I can hold, right? Then I just drop it basically on this page. I keep it for the next page, whatever.
Okay.
So, which reminds me too that I need to basically fit, because I didn't do this. You see why this might be a problematic, but I still need to reset the I need to seek the pointer, right, to read the file from the position that I last stopped. So I probably should do this before I read, right? Otherwise, I'm reading more than I can take. So anyway, and I'll read twice, so that's terrible. Anyway, so just ignore this. This is not a problem for now. So I have my instances now, and then all that I do is that I deserialize these instances, and then I pick the column that I am projecting. In my case, I was just doing a search, and I relied it to be an integer. That's it. I should support like other things, but this would be like indexable types, right? It could be a string, it could be anything, so long as they have comparisons, right?
Mm-hmm.
But then I chose it to be an integer conveniently because, well, F# is typed, right? And I didn't want to handle more types than just an integer, so I just did this. And then you have the value, which is basically the key, right, that you found.
Yeah.
So the value that it's going to be the actual index, and the I is what?
The I. Is this the?
So it's a map I, right?
Yeah. So this is its position in the chunk of instances.
Yes. So I'm basically when I search by the things, I will build a tree. I'll go through the page, and then I'll say, okay, it's this page here. And then I say, okay, get for me, try to find on these indexes the thing where the first is equals to this. And then I go there and I say, okay, just give me a sec. Okay, sorry.
No problem.
Yeah, no, that's fine. Okay, so this would be something like a map. Okay, I just choose a structure because it's less memory, so maybe that's appropriate. But essentially, what we would do here is like this: you would have a value, which is what the user knows, and an integer, which is what the computer knows, right?
Wait,
So
wait. That sentence is huge. Repeat that.
Like think of a hash table, right? What is a hash table? It is something that is physically stored in a computer, and something that the user knows, right? Whoever
Yes.
is calling that knows that. That's why that's the key. It's a common thing that both know.
Yes. Yes,
So
that's the case.
what I want to do is basically, do you agree that this basically has the max of this number?
Yeah, my understanding is that one integer is for the position in the second array, and the other integer is the outer array indexing.
Yes, which is a column inside the array, inside this byte array.
Yes, pretty much.
So why do I get this value? Because that's what the user gave me, right? It is this here.
That is
So
what the user gave you.
yeah, like what I'm doing here is basically just building a map with tuples, basically saying, okay, age one. Let's suppose I'm using a ID, okay? I have like 4 users, one user with ID 1, 2, and 3, 4. And then the first ID would be like at this position here, 1, and then it would map to, I don't know, 1. The second could be, I don't know, 3, and then it's mapped to 3. Let's suppose we insert like the wrong order, right?
Yeah, but that's my question to you. Aren't you assuming that the IDs are actually being sequentially written in the disk?
No, the
No.
IDs are not.
Then
That's
I am
the
confused because you
so
said that this int is the int down there.
so no, wait. There are two things here. This I is mapping to my logical structure. It's not the physical representation on the disk.
It is not a physical representation in the. I think it is because line 123 is basically doing the chop chop of creating instances,
Think of
and
this.
and you
I
are reading
read
by
I
an
read one
array.
chunk. Think of this. I read one chunk. I do 1, 2, 3. Fine. They are the physical order, right?
Yeah.
On the next page, I'll chop another chunk, and they're gonna be again 1, 2, 3, 4, 5.
Okay,
You
now
see?
you are right. Now you are totally right. I see. I completely see that.
So those are like the references. They might correlate. They might correlate with what is on the disk on this chunk, but it's still they are logically
Yeah,
represented
yeah,
for
they
my
are.
array.
That makes sense. That completely makes sense.
So what I would have here is basically just a map of my type. So this could be like a generic thing, mapping comparable, right? Something that implements equality. Maybe I can do this. Mapping to this thing here. So this thing would be basically pointing to what is the position of this array here. So, okay, ID 1 is mapping to this record here, which is on the position 2. So I get that, and that's it. But then and then I yield. But we're still left with knowing how to find this guy, right? Because think of it.
Before you say that.
Okay, go on.
So, my understanding, and correct me if I'm wrong, because I think if I got this wrong, this is going to be terrible. So, this is basically a hash map, as you said, that you are mapping something that the key is something that implements comparison
Mm-hmm.
to a logical ID within a page.
Yes.
A logical ID
So
within
it's
a
as if I
page.
have a bunch of hash maps, basically.
You have a bunch of hash maps.
Yeah,
Okay.
each page you can think of as a hash map in my design.
Okay, so then my question is, so at some point in this process, you're gonna do a comparison between what implements comparable with the whatever key that the user provided. In your case, both are integers, so it's fine.
Mm-hmm.
Okay. What was your question that you left me with?
So, uh, how do I search? I still didn't explain how I search, right?
Okay, that's true. That's true. You didn't
So
explain that.
let's go back to this thing here. So we're giving the pages and the amount already read. So I'm just reading this amount here, right?
Yeah.
If I need to read more, I need to flush all these pages, and then I need to reiterate, right, and read it again based on the where I stopped, right?
Yeah.
That's why I passed down here the amount already read, okay? So next time I would seek to that amount,
Holy
which I'm
fuck,
not
this is
doing
very
currently.
complicated, man.
Yes.
Holy fuck.
And by the way, man, I simplified greatly here. I tried my best to simplify this, but yes, it's still very complicated.
Okay,
And then
go
what I
on.
need to do with that is build the B tree.
Yeah,
So
I
I
noticed that. I
fold,
noticed that.
so I fold with a null pointer, picking the tree and the offset. This offset is kind of bad, but it's the position on the page, right? So I basically have a tree, which is the accumulator, and the element I'm currently folding over from the page. So this is currently the page.
Yes.
And then I
Makes
fold
sense.
again with all the indexes from this page. Right? I need to add like all the
Wait.
indexes for this page, then all the indexes for the next page, and then all the indexes for the
You
next
were
page, and
folding
so
the
on.
pages. You were folding
Yes.
the pages. And then at each page, you were doing another fold
Mm-hmm.
that picks the indexes out of this page. So you're
Yes.
grabbing your hash map and you are folding it. Right.
So I need to fix this, by the way, but essentially I fold the indexes, which is an array of tuples, right? And then what I do in there is that I pick the key, which is the user key, and the array index. I will rename this. This is not really an offset.
Okay, so you're basically flattening the subtrees into a
Yes.
single gigantic
And
tree.
then I build a new tree, like I insert this thing.
Which is cursed because this is Mutation City.
Yes, this is C mutation, yes.
Okay.
and then I basically voila, I have the. I mean, this is mutating, yes, but I still need to assign right to a new
No, this
variable
is
at the
still
very least.
referentially transparent, so it's fine. But very interesting that you do a fold within a fold, and the action on the fold is actually mutate a pointer.
Yes. Uh, I mean, it's not really mutating a pointer, right? It is. I mean, yes, it's still pure if you think about it, because
Yeah.
I send a tree and then I get a new tree.
Yeah.
Uh, it's not like this, but it's still like a pointer. So, but it's not modifying. It's because this function would behaves well. But anyway,
Okay, but I understood what you did. I think you were
so what's the
understood.
problem here? Let me see if you got it.
What's the problem
With the offset, to be specific.
with the offset?
Array index. It's the array index.
Um,
Like think of this. I mount a tree with this keys, right? So I will search in this tree by this key that the user is giving me with this offset. Oh, I know why I used integers. It was because of the tree.
Wait, I don't think I am understanding the problem with the offset. The offset is basically the index, or the logical index of the pages.
Just a sec.
Wait, but you are losing the pages, right? Because you're folding them.
I lose which page, right?
Yeah.
So I have like if I
How
start
do you
over and
know
over
which
again.
page this was originally in?
Exactly. So this is not a problem right now because I just saw a page. But if I have two, then okay, like it points to two. Okay, is it true of the first page or is it true for the second page?
Yeah,
I don't
how are
know.
you gonna know that?
So I need to start both here. But anyway, that's not a problem. We can just fix it.
Oh, holy fuck.
Yes. So in the end, I mount all of this, and then here I would iterate, right? This multiple times to read multiple things, and each time I return these pages, the tree, and the amount I read, and then this guy would handle basically the page loading, and this has the knowledge of what I'm doing queries. So if it's like a restrict, for example, I try to find on the query. I didn't do the all right now, but if I try to find on the tree, I get the last chunk I read. I pick the tree, and then I try to search. I try to search the key, and then this is verbosity. By the way, we can remove that from the API, but I think it's good for debugging.
No,
Uh,
I
we
think we're
pick,
gonna maintain.
we
Uh,
pick a key, so the key that I'm searching for, which is conveniently an
oh,
integer,
line 181. That's how you're cheating.
and then I pick the first page, and
Yeah.
then that's it. So I
Okay.
know that this is the page, right? So in my case, we would have to modify the C code to basically return a tuple here, or a struct that I don't know how to do FF5 a struct. Maybe in Racket it could be easier. But anyway, we will need to return a struct here with two things, right?
Okay. Okay, I think this is enough information for us to get started.
I think so as well.
So I'm gonna
Let me stop
stop.
here.
Yes. So
Now good luck for us.
no, but we have the person with the knowledge of
Oh,
the domain, which is you, and
let's
the
hope.
person with the knowledge of the implementation, which
Let's
in
hope.
this particular case is not Marinho, it's me.
Let's hope we have both. Right.
So at the end, the ideal scenario, you're gonna be more comfortable with Racket, and I'm gonna be more comfortable with databases. That's the goal. So I noticed that we have some constants that you were talking about global variables. I think it would be kind of nice to have this sort of information in the pager.
I
Uh,
agree, but let's just start with the machinery and then we have constants. I think it's
uh,
better to do that way. As
uh,
long as we put them on variables, it should be fine.
yeah, no, that's exactly what we're gonna do. So, for instance, you have instances per page. We're gonna do exactly that. So, instances per page. We also have max pages at once. And the cool thing about this is that Marinho made it in a way that it is tremendously easy to upgrade. So if you master the macros, which is the really the quirky thing about this thing, you can have these sort of powers. So instances per page, and that's it. We are already accumulating those things.
So let's start building.
I
Uh,
think it's better bottom up. What do you
let's
think about
start
that?
building the build pages function.
Yes, that's what I want. So let's start with that. So this is the like I know I kind of have practice with three different Lisps. So what is the syntax for this one? Okay, so this is the one that we do define, and then the name and the arguments go together. Okay, that's good to know. So let's go with the build pages. So what is a build pages should receive? It should receive something
So
called initial
page number,
page number,
the instances you can read in a page,
instances per page, the page bound, which I'm assuming
which is
is
the max amount of things you will read.
we have a reader, which is basically I think a pointer to a file. Is that right?
Yes.
Okay, so we're gonna have to have like a I'm gonna call it reader, and then we also have the instance size, this, and then amount already read. Actually, we have the initial, we have the instances per page, we have the instance size, we have the amount already read. I'm gonna maintain
The,
as it is. Later, I'm gonna change
the
the signature.
yeah, just copy the
So,
header. I think it'll be. Man, just give me a sec. I'll be right back.
okay, this is forcing me to kind of do it like that. Oops. I should, yeah, I should do it like this, actually. Holy fucking Jesus. Okay, so this is ginormous. So amount already read, then we have the attribute to index. Then we have a schema. Then we have an entity name. Then we have a relation to index, which is kind of interesting. Kind of interesting. So what are we gonna use this for? What are we gonna use this for? Oh, okay. So this is for error messaging.
All right, I'm back.
Okay, so I noticed that we have a
But
thing
it's
called a
very
relation to index.
relation to index.
This is just for
So
error handling, so I'm inclined to not put
no,
it
no,
right
no, no,
now.
no. Wait. The relation to index is the key by which you will be putting the index on.
Is the key in which we're gonna put the index
Oh, wait,
on.
wait. Relation to index is the table, right? Is the relation.
Yeah, but how is the relation? Yeah, but
So
looking at the
do you
implementation,
recall
this.
our field? Do you recall our field metadata? Can you
Yeah.
go to our language file? Probably it's there.
Uh, no, I remember that. No, it's not here. I remember that we have a metadata. That's fine. We can even check it out. That happening in the ST.
Oh, is it just being used here to debug?
I think yes. I think this is only for error messaging.
Oh yes, I
So,
am. Yes.
so I'm inclined to
Yeah, just
remove
remove
it
it.
because not because it's not important, but because I think we already have enough things to. Oops. Okay,
I mean,
that's not
what
what
the
I
heck
want.
did you do there?
I have no
Oh,
idea.
you opened Helm as a buffer. That's a problem.
Okay, so let me just jump back to this. Um, okay, so we're not gonna do this right now. So later on we can improve that. Okay, so let's go. So the first thing that you're doing, you are defining some things called like a buffer in an amount already read. Amount already read, and you are making those two things mutable. You're making those two things mutable. I think we're not gonna do that.
Racket. Yeah, we
Uh,
don't need that.
no, we are not gonna make them mutable. That's what I mean. So
Well,
you are
the
initializing
depending
a
on
byte array.
that will depend on the behavior of the read. I don't know how it is.
Uh,
Like this is a .NET read, so I had to. I had no.
um, okay, let me actually see where the heck we are using the reader. So the reader is being used on lines 118, in which we are doing the comparison for to check if the reader's length is minus the amount already read and stuff like that. So this is already an open file pointer. So like this is not even the path to the file. This is already the pointer. Okay. So yeah, I think we can just start with the loop. We don't need. I don't think we need the mutable things. Okay.
Oh, you would certainly need to give the amount you read
No, but we
changed.
already have that.
No, but yeah, but summed, right?
Yeah.
So
So
you would have to
we're gonna
loop and
use the.
modify it all the time.
Oh, so that's
The
why
command.
it was bugged. The caps lock was on. We're gonna do a trick that I learned with Marin. So there is a way that you can make. I think the usual informal way to call it is let loops. Let loops. It is kind of this. So this is how you make like a close sibling to a 4. So what this is doing, this is basically initializing some variables and then iterating recursively, right? So usually
Mhm.
when we need to do something like what you did, what we do, we just grab the a let loop from before, and everything that we need, such as the amount already read,
I see.
amount already read. Um Oops.
Because the loop itself is a is that a construct or is that a hack that people did? Because if you do that on a definition of another let and you call it, you're basically gonna
Okay,
loop,
so
right?
let Racket. Let binding. Local binding. Yeah, this is what the second form usually name as a named let. Okay, so this is not. I was calling. I don't know what I
Yeah,
named.
this is yeah.
Evaluates the
What I
init
thought.
XPRs, so it is basically initializing variables such as n in this thing. The
Yeah,
resulting values become arguments in an application of a procedure where you have access to the things in the binding. So this is how you do a factorial with this sort of let, right? So, and you may ask, why would you do this instead of a fold? The answer is if you want to initialize some crap before, and then you have a construct dedicated to initialization plus a fold. And this fold is kind of based on recursion, so you need to call the function itself within the body.
hmm
So we used this a few times already, and it's so useful. So what we're gonna call this? Let me actually put your code back to my other monitor. So oh, you're using shadowing. Okay, let's do that. So amount already read. Amount already
hmm
read. So something that I want is to actually. So the reader is pointing to which file?
Wait. It's pointing to like the function below is the one that controls the header, right? But it's pointing to the entity name .ndf. However, we are storing the entities.
Okay, in that particular case, just for the sake of simplicity, I'm gonna change this to an entity file path. Then we can go here and we're gonna say that a reader is a particular thing reading a file path, which is very convenient because I know exactly how to do that, which is like this. So thank you very much, previous Eduardos and Marinhos. So we want to read entity, right? We want to read entity. That's what we want to read. And then we can put some entity file path, I believe. Actually, it's a file name, right? So file name, let's change that. Okay, so this is how. Okay, so let me explain. So this is a function that I made with the purpose of having. I can read everything that I want, basically. So let's suppose that you want to read data. Fine. I'm gonna give you the path to read the data. If you give me the name and you give me the mode of sorts, and the default mode is an entity, which means that I can actually remove the noise, which is kind of nice. So I can just remove all of this. So what basically this is doing? So this is basically, oh, convenient. I can just put the entity name. So now we are making the NDF generic file path system, so we don't have to care about which folder is in and so on and so forth. It's
Okay.
going to do that automatically. And then we are opening up the pointer. We are actually opening
Mhm.
the pointer in binary mode. In binary mode.
Okay.
We're going to
Oh, the file
make it,
descriptor, right?
yeah, the file descriptor. So we're going to just do it like that. We're just going to do it like that. So yes, so that's it. Actually, this is also not necessary. So now we have a reader. Next, you are making a buffer, right? A mutable buffer. We're not gonna use that. I don't think we're gonna use that. So we don't need a byte array. This is from the copy pasting. And now we can start doing our stuff, pretty much. So what do we want to do? Oh, we actually need an index, right? So index. So the index is going to be something that starts by initial page number. And the first thing that we're going to do here is check if I
Hunst is over there. Oh, that's a Jew. Hello, Jew.
Hey guys.
are you
Hello.
here to make fun of us again with Milena? We are
Of
live, by the way.
of course, but Milena is making nerd stuff. Just like not this kind of nerdness,
On a
but she's
we're woman. We're
nerd.
Friday, right? That's a verb.
Yeah, Friday night.
His girlfriend.
Oh yeah, yeah. So again, we are live. Every it's being recorded this time, Edu.
If it's on the
Oh
internet, it's
yeah.
forever there.
If
Now
it,
I'm not the nerd and just the watcher.
Okay, so
I'm
let
just
me.
the
Okay, so if you're
gamer.
gonna watch this thing, we shall explain.
What you're
Well,
doing?
you picked the worst possible session ever
Yes,
to
I
watch
Oh,
do
this.
think so. I think I recommend.
is this is
I
this
think I just
racket?
spent a half an hour explaining what I did there.
Okay, so
Is that
yes,
racket?
yes, this is Racket. This is Racket.
Oh, I see.
So what we are doing is the following. We
And there are
are
flakes for racket.
yes, well, we are not using. It's kind of cheating because it's only Nix develop.
Uh,
So we're not doing Nix infrastructure to make the compilation and the reproducibility. We're basically just acquiring the tooling.
all right.
Okay, so
And
what we
what
are
you're doing?
doing now, let me try to explain what the heck we're doing. So we have a database, right? We have a database, and let me
Mhm.
show you what that means. So we
You
have
you mean a database manager that you wrote?
um, a database manager. No, we are creating the database. The database, like
Yeah, it's a full
What?
blown RDBMS.
yeah. So
I mean, it's a trashy one, but yes, it is an attempt to do one.
no,
Very
we
nice.
not we never claimed to make a commercial one.
Ah, yeah, yeah.
Anyway, uh, I don't know if you ever studied this, did you? But when you have a relational database, there is an entire full-blown relational model Wikipedia.
Search for relational algebra.
No, relational algebra is better actually. Algebra, Wikipedia. Yeah. So this thing here. So this is the math. As you can see, Greek letters. So this is definitely math.
Oh yeah.
So this is the math that explains how you can make relations. But in the implementation side of things, again, denotational semantics, operational semantics. I think you remember that.
Yeah.
So operational are tables. That's basically
Mm,
it.
Yeah.
Uh,
So and so the problem is like people added SQL right atop of the relational to represent the relational model.
Yeah.
if you go up, can you just scroll, Lemus? And it has some consequences. Like for example, the projection that you see there, the pi operator, that's actually a select in SQL.
For some
Okay.
random reason.
The sigma, which is
Alright.
the selection, is actually the where, right? So these things are kind of like muffled by SQL, right? It became like the standard basically for,
Yeah.
and it does very poorly at presenting the relational. Like if you read the original paper, man, like it's totally off because there's a lot of things there that like are misrepresented or they are just plainly wrong,
Yeah.
right? So that's the
So
motivation.
you're trying to implement something that it's more adherent to this.
And we are
Yes,
at least
something that
trying.
is
We are
more
at least
correct.
trying to do that.
So, for example, like there should not exist a constraint, for example, in SQL called unique. Like that should not exist because the point of having a element in a set is that this element given by the key of it, which is what I call the ontological, is the key that gives the meaning of the state of this row, should already be unique,
Yeah,
right?
the key is
So,
kind of like this. It's the
so
like
if you
the
have something, so if you have something normalized, it should be the standard in a relational model. That means that you don't need to have anything like any rows like with a constraint unique. Like that makes no sense.
Yeah.
The unique just exists because you need to handle nulls and nulls. They well, you can't compare nulls, right? That's the problem.
yeah. So a long story short, Mageta got became an expert in all of this.
Expert, yes.
Yeah.
By
Then
quote.
then he started making his own thing in F sharp, which is this. And then I asked
Okay.
him, let's try to do it in a project. And then we started doing this. I don't know, 8 months ago in Okemo actually. And then
Oh, I remember.
And
Yeah.
then we suffered, and then we
You
stopped.
suffered.
we made it. We made some improvements to the point that Mageta even
And,
copied some of it.
man, dude, I gotta say the problem was not the language.
It was not the language at all.
Yeah, it was the tooling. Like
Yeah.
it's terrible.
Then we decided to go to the. We attempted to go to the extreme opposite, which is Racket, which it has tooling for everything reasonable, right? They don't have B plus trees, but I think it's a little bit too much to ask for that in 2024.
Yeah, I agree.
Like people did it in C, so you just do FFI and you are good to go, right?
Mhm.
So now this is the context. So what are we doing today? So today we
You're
are
implementing the data structures.
no, we already have the data
No?
structures. We are implementing what's so-called a pagination, right?
What is
So
that?
pagination is the idea that you have searchable chunks of data. And why the heck would you want that? Is because if you have a petabyte of data stored in a tape or hard drives, and you're gonna have to load all of that shit in order to do a query.
Mm.
So we're gonna steal the concept of pagination from the operating system and divide the data, like chop the data into chunks that we can actually search
Not even
more
search, but
efficiently.
The
operate on,
operational
right?
system doesn't do that already in the
No,
It
files.
does, and like some databases, but you still have to have some fine over the pages, right? But I think for our example here, it was simpler to just do our own.
yeah, I think
But
it's
yes,
important
I
to you
think
to
SQL
understand that
Server.
we are making the database itself, right? So you said, doesn't the operating system already do this? The answer is yes, but we can't depend on the operating system because we are this piece of software that is handling the data
Uh,
for your application.
yeah, but here's a difference as well. Like the operating system will handle the data, right? But it will
Yep.
not handle like the metadata that you need to attach to it. So you will still have to like have a page,
Yes,
your
yes,
own
yes,
page
yes,
pointing
yes,
to
yes,
like an operating system
Uh,
page, right?
yes. So what we are doing today is we need three things to finish the milestone of this project. We need pagination. We in order to have a more realistic approach to database because if we just go grug and just load everything to memory, that's like what's the point of like that's the first thing. We need indexing to make the things easier
Kind
to
of
search via the B3,
performance.
the B plus 3.
Yeah.
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 Otherwise, it's just serial search, right?
Yes, otherwise it's just serial search. And we need a query language, right? Because we already have the server. The server is already waiting for the query language to be done. So the ideal scenario is you start a server that is connected to the database, and then someone, ideally in another network, another place, connects to this server and sends a query using our query language, and we're gonna parse that and do the procedures necessary functions to acquire the data that the user is asking for. So, and this is part of the whole schema that we have in mind, which is again, this is still crazy that we can, after this is done, implement this integration with our language. So our language uses our database.
Mm.
Uh, so it's like we are making the pieces slowly, but we are getting there. We are making the pieces to have an ecosystem. And then
Yeah.
you may ask, what's the next step? Well, Magenta wants to do an operating system
The
at some
next
point.
step is to implement React.
Oh man.
Have their own web framework. Have their own web framework, Magenta. Imagine that.
that that is not something I would want to be here to be doing, but well, okay.
No, we're not gonna do.
And funny enough, like we have the bot, right, that
Yes.
uses a database. If we get this working, we could even use that.
Yeah, we can actually swap the. What am I using in that shit?
Like, can you show the Emacs client? I think I have there already. Go.
I think we already have the Emacs client.
Yeah, I just stole that one. I actually improved a little bit, so we could use
Yeah,
it.
so this is the necessary Lisp code to
Ah,
connect
come
to a
on.
server.
There are JavaScript there.
No, yeah, this is not done.
Yeah.
Ah,
Basically.
who else, right? Who else would it be?
So these are the front ends that we did like just for fun. So we have a Clojure one, eLisp, F Sharp, JavaScript, and Racket.
Yes.
Yeah, so it's that. Okay,
Oh,
so
here,
then
I improved a little bit, by the way, the Lisp one. I'll paste here in the chat.
okay, later on I
The,
can
the
improve
question
this.
the question is, does it work?
What?
Can you save some
Oh
data
yeah, we can save
Yes,
already.
yes, we can
on a
save.
data structure and
Yes,
recover it?
yes, we can.
We wait. Recover like we can, but you need to know where to fetch. Right? We are doing the search today.
Yeah, no. Well, your question is, can we write some data onto the disk and read it back and have the data structure, original data structure back? Yes.
That's a start, right?
Yeah. So in relation of
But you don't have any mechanism to query
yes,
any
we don't have
specific
mechanism
data.
to create. That's what we are doing
Yeah.
today.
Okay.
We are doing the baby steps because even though Magetta already did it already, this is still like a
Yeah, these
draft.
two very
These
Uh,
query things are always searching.
So
Magetta, go.
depends on the way your query is, right? If it's like you see this function that I have there, 163. There's this projection param, which is just like the parameters you're gonna select. So, but
Yeah, because
right now,
in data in SQL you would do something like this: select name
yeah, name and then
from
table
person
where, yeah, where
where
ID equals true. I don't know.
ID equals true. That's kind of like what we
Yeah,
are doing.
yeah. So we're doing hard coded now in the like forcing the behavior to be just equality on a column, which is indexed, right? So we're just doing the pagination so we can read, and then we can use the B3 so we can search based on the ID. And then we can do like arbitrarily complex queries with like comparing like between two dates, like sort of stuff, like doing an ends and all of that.
So yeah, this thing it's not too incomplete SQL, but it's still very powerful. Like you need to have some sort of notion of operators, and this can go crazy. This can go crazy. But to be fair, they had like 20 plus years to make it crazy. We are doing this as a hobby.
Actually, okay, yes. Like some databases, like SQL Server, has been there for what 40 years by now. So
Yes. So they had
yeah,
the time and they have the workforce to do whatever they wanted.
yeah. But think about this: they did that in assembly. Just telling you.
Yeah, that sounds hardcore.
Yeah, that's really hardcore.
And
So
from the ground. So they didn't have like a reference for that.
no,
They just started doing
I'm not saying that they're shit. They're
it. Yeah, man,
great.
just open this one here. I think this is the best database around.
Is it Postgres?
No,
Okay.
it's IBM's DB2. It's used on benchmarking. If you go like on the what was the name of the concurrent programming benchmarking thing? I don't remember. There's this like competition of like supercomputers, right?
Hmm.
Mhm.
And they use like the models. All of them run inside DB2, which is like a proprietary database from IBM. That it's man, look at when it was made in '83. That is old,
Wow.
dude. And it has like it is the most complete in terms of like it has like a very thing to the initial relational model because guess what? The first people who did it were there.
I guess that makes
Uh,
sense.
yeah, so like CV Bate, for example, got it
Oh.
there. Cod basically was a researcher at IBM as well. Oh yeah, it's in there.
Yeah,
So he
so
was a researcher. It
very
just
cool.
suffers the sin that it does cool, right? That's the sin.
Okay. So anyway,
This thing is
that's
still supported.
Yeah, dude, this is like rocking this day. It's amazing.
it is amazing. Mageta is saying that. That's
I,
a
I
lot of
wish I wish I could work with this. This is really great. The
yeah.
problem with this database is that it's very hard for them to do like it's like on the contract they often put a disclosure that you cannot like put like benchmarking and all this stuff with the name. So it's very hard to get those things.
Yeah.
But, well, unofficial benchmarking tells you that that's really great.
Okay,
And the
so
feature wise it's
enough of context. So let's go back to the code. So what we are doing is basically mapping and attempting to improve as we go along this code in F sharp to our implementation in Racket. Yeah. That's what we are doing.
okay. Let
Yeah,
me go back
sounds
here.
fun.
So okay, so let me go back to what I was doing. So Mageta, in F sharp, you're using a for loop computation expression, and you are doing you know how this is actually the main case that we didn't go with the fold. Another important hint that you're gonna use these special lets. So if you want to do a fold for a established amount of times, apparently the least p way in Racket to do that is to use those. So that was the main reason actually. Is
Okay.
if you want to have some variables set like these ones for the like before the loop starts, you want to have something already like in the environment in the scope, and you want to loop it for a certain amount of time. So we want to go from initial page number to instances per page. No, with steps of instances per page, right? And until we reach page bound. Is that right? Mageta?
Wait, repeat, sorry.
We
Got
want to
distracted.
start the loop from the initial page number,
Yeah.
increment by the instances per page until we reach page bound.
Yes, this is the step in the middle.
Okay, so
And
we're
by the
gonna
way, notice that that is inclusive. Like the for in F sharp
yes,
is inclusive.
yes. So this is what we're gonna do. So after you are done, which basically means we need an accumulator, right? So pages.
No, it's not really the for, it's
Uh,
the sequence.
what the heck we're gonna do? What the heck we're gonna do? Okay, so instances and indexes, right? Instances and indexes. So you're doing let pages to this. Let pages to this. So okay. So a page so it's basically gonna be like an empty. I think it's like this. I think it's like this. This. Okay, so you're initializing our pages with only this, with empty things. I don't know if this is how we initialize a vector, but that doesn't matter for now. If this is equal, we're just gonna return the accumulator. Otherwise, we're gonna do this body. So the first thing that you're doing there, you are creating something called amount to read. Amount to read. That we're gonna do the equality that you were doing there. This is actually better to just
Yeah.
copy
So
paste
yeah.
there. But of course, this is a Lisp, so this, oops, this, and oh, and now we gotta backtrack again because you need to do that, then that,
Mhm.
and then that, and then you are grabbing the length. You are actually grabbing the freaking length. So I think you want to read the. This is
By
not.
the way, this is so annoying that the length is by the way, int
Is what?
64. But
Oh, in
it's an
64.
int 64, yes.
I see your
I mean,
pain.
understandable, but
Yeah. Okay. So what we're gonna do instead of having the file descriptor, we're gonna read already because it's just worth it. So let's go to I don't know read module reader. Yes. Thank you very much. So what is the function that allows me to read? It is this. Thank you very much.
4 bytes.
Yeah. So we're gonna
That gives
just
you
gonna.
just binary, right?
Yeah. This is just giving me binary, straight up binary. So I'm
Mm-hmm.
gonna copy this thing. Copy this. Okay, I'm so happy Marinho's not here. He would cringe hard because look at the size. Look at the size of this thing.
Just rejoice in the suffering.
Like this has three function calls in from inwards, like outwards actually. So you need to start reading from the middle. Like this is the worst case for X expressions. Anyway, hilarious. This is wrong, and then this is probably like that. Okay, so something is wrong with the oh, there is an extra parenthesis, that's why. Okay, so now the reader is not actually a reader, this is actually content. So now you want to know the size, right? And then so then you can subtract that from the amount already read. So we're gonna do something like a function call, and then we need to discover. I think it's like bytes. Yeah, in the same place that this is in, we're gonna find.
Bytes to string.
Yeah.
It has the encoding on it as
Yeah,
well.
yeah. This is
Oh,
very
by the
useful.
way, let's use UTF-8
We
already
are
if we
already
can.
using that.
Okay, great.
We are already using that. So I actually want to see length. Thank you very
I'm gonna
much.
store emojis on the.
Bytes. Content. Okay, good. So now we have this. We're not gonna have then because this is a Lisp dialect, and then we also don't want to do that. Multiply, and then this, that, and then that. Okay, something is still wrong. Of course it is because we have this. Um, okay, this is very inconvenient. So let's actually change this to a let's star. And let's say that oh man, I'm doing closure lets. That's why it was wrong. Okay. Uh, so length, content length. Let's say so content length. And this is gonna be bytes length of content, and then we can just swap. Oops. Swap this with content length. And the same is going to be applied to this thing. So we're just going to boom, 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 boom. Content length. And this is not how you do that. It is kind of like that. It is kind of like that. And something is still... Oh no, I think it's right. The highlighting is all right. Great. Great. So now we know how much stuff we're going to read. Now what? Now you mutate. We're not going to do that right now because we're only going to do that in the recursive call. Then you ask the reader to read this amount of stuff. Right. In that particular case, what are the arguments? This is definitely the buffer. This is the amount, and this is what?
So this is the previous. So buffer, the amount to read is the last, and the chunk you're reading, that's the middle.
Wait, this is the chunk you're reading.
Yeah, this is the amount of bytes you're gonna read. Based on
Starting
the
from here?
page number and the instance size. That's the offset. Wait, man, let me read this.
Oh,
this
you were
function
you
again.
were you were jumping this amount.
I need to read the I/O thing. Just give me a sec, because this function has overloads, and I don't know what it's doing there.
Okay, my bet is that you are jumping like almost like a
Yes.
seek
Yes.
thingy.
So when overridden, so it's this one. Reads the sequence of bytes from the current string and advances the position within the string bytes are read. So yes.
Okay, so this is an effective operation, right? So because you're doing ignore, so I think you're just jumping the pointer.
Yeah, so the second position is the offset and the count. That's
Okay,
it.
we also not gonna do that this way because we have a very useful function for bytes in Racket called subbytes, which basically does slicing. Very useful. I use it all the time during serialization, all the time.
Well, that will help on the chunk by size, but not on there.
No, it's gonna help from there because we just gonna say to the sub bytes, start from here and go. We're gonna have to do a plus here, right? So unfortunately, so you're gonna have to
That's
be.
on the disk, right? So this function you said, byte, it's splitting a byte that's already on memory, right? That's different.
No, but oh, okay, you're right. But we already read. It's already in memory, my friend.
Yeah, but you need to read a chunk, right?
But I have a question. So how does F sharp knows the length of something without reading it?
Well, you can seek, and then you have on the file stats. You can have that.
I see. Okay, so I was doing it. Oh, so, okay, so this is actually not fixing our problem. This is actually the problem. We cannot just do what I just did there. Cool. That means that this is actually a reader again. So now we need to understand, we need to search if Racket has such capability. So open input file. Open input file. Let's see the type. So I want an input port. What can I do with this shit? What can I do with this shit? So can I ask the size? Because I don't know if I ever seen something like that. Can I know via the port the entirety of the size? That's a very interesting question because you understand the problem, right? We cannot just do what I just did. We're gonna have to do something in here with the reader, right? And that's what I don't know how to do. Okay, so the port can get me how many lines we have, apparently. Next location, file port, structs. Okay, let's actually go here first. Close, blah, 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 blah. So how can I know?
Man, I hate this so much, man.
What do you hate?
This everlasting navigation on the documentation.
Wait, but are you complaining because you cannot search for by the type signature? Is that what you're complaining about?
No, I cannot search by the name. Like in
What
how
name
do
would
I
you give that?
discover? Man, let me tell you how I discover things on .NET, okay? I type the module that I think it is, and then I see, okay, function that does this. And then oh, this is nice, it does that. Then I tap, and then it
Yeah, but you
completes
understand that
magically.
you're basically doing Control F on here.
Yes, well, but in the LSP, right? So the feedback is way less, is way faster.
Well, I think I can habilitate LSP. That's not like
Yeah, but
impossible.
it's not working by the same way of the module. Specific name of the function. That's the trouble.
Yeah, I think that's one of the things that makes the learning curve steep is the fact that well, at least for me, I prefer searching for the type signature because Google, of course.
Yeah,
But
Hugo is great. I gotta say.
we here we don't have such a thing. Although they kind of
Yeah,
have
but
sort
let
of.
me give you an example. Even what's the name? Even Erlang has that. Like how you can type the name of the module and then you discover the functions, right? That's great. Oh, look who is here. Jean is here. Jean
Returns the
Vauban.
number of bytes contained in a pipe, where pipe port is either of the pipe's ports produced by big pipe. The pipe's contents length counts all bytes that have been written to the pipe and not yet read. Okay, so this is not what we want. This is not what we want. Um, port bytes, port
What
lines,
function
byte
are you searching,
lines.
by the way?
We
I
are
lost
searching
one.
a function that allows us to pick a port and returns us the length of the file descriptor of the file that the file descriptor is pointing to. That's what we want because that's what we were doing there. And what I was doing before was wrong because I was actually loading into memory, and that's the problem because maybe there is a petabyte there. So I cannot just do that. I cannot just do that. Ooh. Merge, open. Hello, Jean. Hello, hello, hello. Doob, relocate. The names are great though. Transplant. Ah, the names are great. Peak string. That's a Jew for sure.
Oh man.
That's a Jew for sure. Um, the thing is, usually the ones that are really great in doing the query of these things in the documentation is Marinho. Marinho is very great on that. So do we have something like port length,
Oh man, Edil doesn't know this guy. Listen here.
size, transport size?
Talk, man.
Assign.
Oh man, this TED talk is like. I highly recommend, by the way, Edil.
What did you share with him?
It's a TED talk. Oh man.
Display handler, file identity, match, next location. No, that's only one. No, also no. Okay, that's a very weird function to have. Number, position. What is the port number?
Man, this guessing is just. Yeah, I
Port for
guess
the
it's this
Intune is
function.
default. Wow, this is very old documentation. Holy crap. Try file lock, waiting peer, write special. Wow, imagine if we didn't, if this is not a thing in the language, that's gonna be fun. Okay, actually, just for the sake of having, we can go further. I'm gonna cheat, and we're gonna load everything in the memory, and we're gonna
By the
pretend we are
way,
not doing that.
is there anyone watching this, by the way?
On the stream, no, but we have two of our buddies here. Okay, so
He's
never
here
mind.
listening.
Okay, so let's just do what I just said. I can search for this later. I can ask in the Racket's Discord server. Doesn't matter. Uh, for now, we can just load into memory for now. It's just to have something working. I'm fine with that. I understand that this like kills the purpose because we are basically doing what we are trying to avoid. Uh, but it's uh, part of not knowing the language as we wanted to know. As we wanted to know.
We're just gonna load everything.
Yeah, and but we're gonna pretend we're not doing that.
Yeah,
So
after all, what's the point if you're doing that?
no, yes, exactly. That's why we're gonna just pretend we're not doing that. Okay, so then we are making instances. So let's make instances as well. Why not?
Mm-hmm.
So instances.
Man, Source Hut is still down. What the heck?
Wow. So you're gonna pick the buffer.
Oh no, it's
Uh,
not. Back.
you're gonna pick the buffer. So actually, I'm gonna make something here. So let me put something here just for the syntax.
Oh no, it's still.
So let's make something like buffer. And in here, we're gonna do what you're doing that, but we're gonna do that virtually because you're already loading everything to memory. So this is gonna be bytes, sub. Is this from where? Sub bytes, yes. Then I believe you need to pass the contents, and then you need to pass the indexes, right? So we're gonna do something like um, initial position, and this is gonna be the multiplication of the page number and the instance size. Yes, instance size. Then we're gonna do initial position, and we position, and I also typed that wrong. And then in here we're gonna do a plus of the initial position with amount to read. That's what we're gonna do there. Yes. So this is basically jumping, grabbing, slicing the content from initial position to whatever that is.
Mm-hmm.
We're gonna make
Just pay attention to the intervals as well, because
fix
if you
me.
chop one byte, it will not serialize correctly.
Um, this should disappear once go we go back to file descriptors.
Is this supposed to be like this with a dash and the others with camel case?
Uh, that's a convention in I think only on our project. Or am I just going crazy because of Objective C? Yes, I think I'm just going crazy. Everything should be not camel case. I'm doing this because of Objective C. They're hilarious, hilarious.
But does it work?
What do you mean, being camel case?
Yeah, because
Yeah.
you define initial position with a dash and you use it.
Oh no, this is just wrong.
Ah, okay.
This is just
Okay.
wrong. This also should give a fix me. This is nonsense. Why pagination if you gonna read it all? Find and then find how to grab the length of the file using only the port. You dumb. Cool. So now we can make the instances. So we're gonna pick the buffer. And we're gonna do a chunk by size, instance size, and then we're only gonna take the page bound. I see. I see. So what we're gonna do about that? So we're gonna go to list. So chunk by size is a very bad name. How would you group?
Uh, I think it's not really group, right? Because group will group by an attribute in the list. You want to
Yeah,
group by the size. So,
yeah, but what name would you do? Would you give that function?
well, I think chunk by size a good name.
Partition.
Partition, yeah.
No, but this is only doing the split. This is Haskell split. That's not what we want.
Yeah, it's just this.
So filter map, remove duplicates, check duplicates, flatten, add between.
How does Nekoma call it?
That's a good thing to ask. Prefix, drop prefix, split at right, drop right, take right. Well, we're never gonna be able to, we're not gonna complain. I think we found only one function that this library from Racket doesn't have.
Oh man, you gotta be kidding me that you need to do an man. You need to iterate and take. Like, you need to iterate and take. So, but there's no function. You need to do it yourself.
Yeah, we like this is the sort of but that was a common theme in Okemo. And you know what people from Okemo told me when I complained about this?
Mhm.
Oh, you don't want to code yourself, you lazy. And I was just like, wait, what?
Yeah,
Like
man.
I'm like I know how to do it. It's not because I don't know how to do it. It's just because like why would I do
Well,
that?
I expect the bare minimum of the standard library, but
No, but they say this in a like a proud manner, like that they
yes,
code they code their shit themselves.
all the time. Yes.
Like yeah, exactly, all the time. I,
Well, I
I
need a
really I
B-tree.
really don't
Yeah.
understand.
Look there. I sent one.
Wait, split by?
Yeah, you have to define it. Right?
No, wait, where did you get that?
Oh, Stack Overflow.
Oh, so there isn't in the.
No, yes, from here.
Awesome, awesome. And split into chunks. So which one did you copy pasted? You copy pasted.
The 1 6 because I thought was simpler.
Okay. So people from Okemo, be happy. We're gonna be using our own shit.
Well,
Goddamn Objective C, man. I'm gonna have to change all the names after. Goddamn. Okay, so then we're gonna do split, split by,
yeah, man, there is nothing. What the
split
heck?
by. We're gonna what is the list and then the n. Okay, that's cool. So we're gonna pass the buffer and we're gonna pass the page number. No, instance size, and then this we're gonna oops, we're gonna also call another function that's gonna do a take. And take, I do know they have it. Take. Reverse, fold, sort, last, take. Thank you very much. So I'm gonna take, okay, so then it's take on this, but we're gonna actually do that with how many things? Page bound. Page bound. So there it is. There it is. Okay, what next? So now it comes the hard part. So this is how you make the indexes. This is how you make the indexes. Um, sure, sure. So I have a question for you, Magita.
Hmm.
So can you remind me what the heck the yell does in F sharp? And if
The
you say like
yield.
Ruby, I'm gonna say I don't know Ruby, man.
This is like the add this to the list of the computation expression.
Oh, okay. So this is what you're gonna call the fold.
Yeah.
Cool. So we're gonna do something like indexes. Then we're gonna do some computation here. And after this, we are done with the let, finally. And then we're gonna call the function recursively. So loop, and then we need to update our stuff. So we need to do amount already read with amount to read. Yes, that's cool. So amount already read with amount to read. So that's the first. The second thing that we need is the content, and the content is well, this would already be done because this is mutation, so we don't have to care about that. But in our case, we're gonna have to do that. So we need to pick the content. We need to pick the content. We need to pick the content. Uh, and we need to jump a certain amount. We need to jump a certain amount. How much things should we jump? We should jump this amount.
Yes.
We should jump this amount. Next up, okay, so this is already getting to the. I'm using an ultra wide monitor. This is getting to the point of doing this. Yes. So the next up is the index. The index is easy. It's just a +1. Oh no, it's not +1. It's instances per page. It's instances per page. And the final thing is the accumulator. That's the final thing. Okay, so we're gonna do pages, instances, indexes, and that's it. So this is the calling recursively the loop up there, if that makes sense. Now we just need to make the indexes. And I also noticed that I removed, this is still a file descriptor. I need to make the cheat again. So how do
Okay,
you
don't
read
you
it?
need to close that, by the way? Or is
Sorry?
that... Do you need to close that, or does it close by itself?
There is a function, very, very useful, called call that does automatically the closing.
Oh, I see. It's like the weave
Exactly.
file, right?
Exactly. So port bytes. Yes, that's what I want to copy paste again. So let's grab that. Let's go back here. Boom. Um, let's grab this and throw it in here. Um, that's not what I wanted. Wait a freaking second. Yeah, no, that's correct. That's correct. Okay, so now, wait, is this correct actually? No. Yes, now it is. Okay, so now we just need to make the indexes. Awesome. So what is this supposed to do? What is this supposed to do? It picks the instances, does an array map I, which basically means doing a map having an index. Then it does a lookup deserializing the schema. Deserializing the schema. So how we gonna do that? I think this is actually enough to make a separate function. So let's do that. So define create indexes. And what this motherfucker should receive? It should receive the instances. The schema.
Man, you sound so angry doing this.
No, I'm not angry at all. And the byte array. And the that's pretty much it. So now what we're gonna do? We're gonna do the map I. So let's pray that we're not gonna have to do this. It's only a zip with with a range. So
Yeah.
it would not be the end of the road doing it, but I would like to see uh, if they
Search
have.
for a zip. Do they have zips?
No, they have zip. I think I know.
Then they don't.
Okay, so apparently searching by map, they don't have zip in this module. That's not to, but there is another list module that I already know. Don't ask me why, but they do have that. Okay, this is a bad sign. So these are all third party. Racket. Like they have very unique stuff, but they don't have a zip. Like, they have very cool stuff, but they don't have a zip. And I really don't want to make to add a third-party dependency. So this is indexing. I kind of don't want. I kind of don't want. No, don't care. Is map overloaded? That's a good question. Is map overloaded? Because there's a chance it is. And if it is, yes. It is overloaded. Okay. That means that we're gonna make ourselves. That's what it means. So map. So what it means to say it's overloaded, right? So map has a special overloading that allows you to provide two lists to it. And then it's gonna basically do a zip, and then but the function that you provide to map needs to receive two things because it's gonna take one from the one list and the another one from the other list. Okay, Magetta?
I I think so.
Okay. So what we're gonna do is basically there's gonna be another lambda here. So lambda blah. Then in here we're
Mm.
gonna have the instances, and then here we're gonna make a range. And I don't recall the signature of this. I don't remember. Do we need it to be inclusive or not? I think the
In
answer
F
is
sharp, the ranges are always inclusive.
the ranges because this is basically saying like start the 10 and the 20 is here in inclusive range, but in range it starts
Mm-hmm.
from 0 and goes to 9. I think we want range actually. I think we do want range. Is this map I starting from 1?
Oh no, if it's gonna map the array, yes, it's just positional, right? So it's
Yes.
not inclusive. Yes.
Okay, so let's do range list. No, Marino told him that we don't need to do that with lists because the full length function is for lists already. So instances. Nice. So we're gonna exploit the map accepting two things, which means that now we can say an instance and an index. And for the sake of being similar to Magetta's, I'm just gonna say it like this: index instance. What do we do in this lambda, my friend? We
So wait, you're looking at this array mappy, right?
yes.
So all that I'm doing there is I'm deserializing, picking the key, and then mounting the index, which is the tuple there.
Okay. So what is the serialize providing you?
The deserialize is composing back the object so I can pick the column, right? That I care about.
Yeah, I understand that, but you see that you have something that you receive as a value. So this is actually deserializing data.
Yes, and then I pick the attribute. I try
Uh-huh.
to find it on the map.
Uh-huh. So then my
That's if I
understanding
find.
is that how do we do we just throw exceptions? Read.
Oh, I do a fail if we can do the same.
No, but you are doing a pattern matching there, so I think table
Yeah, pattern matching that
values.
results into X.
Okay, so this is the function that we're gonna use to do that. And I don't believe this function accounts for failure. Uh, oh yeah, it doesn't account for failure at all. How nice. So that means that in pure and genuine Magetta style, this is not gonna have any error handling.
I mean, it does. Yeah. Oh, mine did. So you are just
Data.
misrepresenting me at this point.
No, but you did, but you remember what we were doing in Okemo, right?
Oh, right. Yes. That was terrible.
Read table values from this. This is not reading the entity. This is reading the values. We're gonna pass the schema and the entity name. And we're gonna get data out of that. We're gonna get data on that. What do we do with such data?
Well,
We just return it.
so here's the thing. I'm wasting because I'm deserializing twice, right?
Wait, why twice? I'm seeing only one call.
Go down. Go down.
Uh,
There.
there where? Am I
182.
blind?
182.
82. Oh.
You
Okay,
see?
yeah, that's kind of.
So that's kind of bad. So ideally we would just do once, right? Or have caching, and then this wouldn't matter. But for now, I vote for the simplest
I vote
implementation.
for
which
the
is
no. I vote for to do the same. But
Man,
it's
Jean is with me, man. Like, look at the infinite. Nobody got time for handling errors.
software engineering 2024.
Yeah, this dude knows, man.
Ah, so good. Okay, so this is basically just okay. We don't even need a let to do this scrap then because we just can do like this like that, and then we can just return values uh, that and index. Yeah. So I think that's pretty much it. That's pretty much it. It's kind of meh that if we swap those two things, we could do partial application. Hmm. I'm not gonna do that right now. Okay. So is that it? Actually, this is not there. Okay. I think this is it actually. So instead of we just call it. So the create indexes.
Can you leave a to do there? Like
Where?
just warning. Like we're not error handling. Whatever.
Okay, I'm gonna leave it to do there. That's fair. So uh, to do to do. This function should account for eventual errors. LOL.
Well, just I would specify what kind of error, right? Which is
There
trying
are
to fetch.
two at least. File not found. This is just gonna explode in this line here. Uh, Maybe that's fine actually to explode if the file is wrong.
And on building the key, right? You might
Uh,
not find the key, and actually that should be validated up front. That's not a big deal, I think.
no, if you provide the name of the entity wrong, we're just gonna explode in your face, and who cares? But the
Yeah, but
problem
one
is,
thing is that there should be something that upstream already validates this, right?
oh, you're saying that we should do this hash f should be done earlier.
Yes. So
Okay.
like we don't want to like just
To
increase this
do
validation there.
this validation should be done in the caller.
The only error left on that context is the things that are not supported, right? You're trying to index something else not supported.
No. I don't think so. I think the error with this is that nothing in here is assuming that the byte array is completely bogus. Like this is assuming naively that that okay, we search for the file, we found it, we read it, it is in the schema,
Oh no,
and
no, yeah, not on this function, right? This function is fine. I'm saying one you just did the build pages.
oh, okay, so the create indexes.
Yes, the creating.
Okay, oops, let me save this also. So what do you want me to put in here to do?
Just put a thing like that only works for supported. Like leave an error message later, only to only work on the supported types. Because if we receive a blob of like bytes, let's say to store, then we're not gonna index, right?
see, I
Although
see, I
some
see.
databases do index it.
I see. Okay, so next question.
It's crazy.
This function that we just created, the inner function, right? So this inner function, Bioju, thank you for being here.
Seju.
So yeah, this function here needs to receive a byte array. It needs to receive a byte array to create the indexes. So this is doing the stream. So this needs to come from the instances. It needs to come from the instances. We don't need the byte array. I did it wrong. Okay, so now this should work. Theoretically, it should work. So this is it. The only thing that it is completely like this fix me is very important. I think my priority is that fix me's are like up there. Like this is like just nonsense. And to dos are kind of like you can live with it for some time, but at some point you're gonna have to do something about it.
Okay.
So aside from the fix me, which is that I need to discover how the heck to get the length of whatever the port has access to. Aside from that, everything is so far pretty one-to-one, if you ask me. Aside from the mutability. Uh, Well, we're gonna mutate. Once we go to the port, we're gonna actually mutate. So it is what it is. So let's try. So do we have data? That's a very good question. Do we have data ready? Oh yeah. Okay. So do we need more, Magita?
Um, I don't think so.
Okay. So we already have the programmer table.
So here's the thing: we did the building a page, right?
Yes.
We still need to do the build pagination, but
No,
I
we're
think
gonna
we
make
can
all of
stop
them, but I
here.
want to test this.
Yes, I think we can stop here. Like, so let's just test this function here. So
Oh, wait a second.
yeah, you need to
Wait a freaking
return
second. I need
the
to return
amount
the
read.
amount already read.
Yeah.
Okay, so was an oversight. So let's do that. And I also remember something wrong that we did already. Also, uh, this can't be done like this. Actually, right? Uh, this can't be done
Can we
like
summon
this.
our code from the REPL? No, we can, right?
Well, I think we can. This actually needs to be a cons because we need to accumulate this thing. But I have another thing. Oh no. Now that I fixed this is just a matter of changing this. So we're gonna
Man, it's
return two
raining
things.
for
So
6 hours by now.
what?
It's raining. It has been raining for 6 hours.
Wow, that's a lot. Amount already read. Okay, so now we can make a function called uh, test build pages. So what this function should receive? This function should receive. Um, oh fuck. I think this is kind of wrong. Is this just highlighting? What the fuck? Oh no, this is because this is Racket. The first thing is the name of the function, you idiot.
Yeah,
Okay. Man, I always need to remember. Is this common Lisp closure a Racket?
you are like a
um, okay, so how should
invest.
we test this? How should we test this?
Oh, just open spawn the REPL and then you load from there. Like, try doing a call. You already have the file, right? The NDF file. I mean.
I already have the NDF file, but I want to know what do I put. Like, let's try to call the function. I'm actually not gonna make a test like this. Let's actually just copy paste. Like, just copy this. Maybe that's why they chose this syntax because it's so easy to just copy paste to make an application. Hmm. Interesting. So let's try. I'm gonna call a function called build pages. What is the initial page number that you say? 0?
Yes, it's 0.
Okay,
Page
so
number
0.
0.
Instances per page, let's put like 1.
True. Actually, that should be from the size of your page, right? In our case, since we how much you're allocating on the buffer, you don't need to do that, do you?
No, this is the data that we are. No, this is the data that we have
On
serialized.
the function, like I had to cap the amount of bytes you can put on the buffer. You didn't do that,
I
did you?
didn't do that. I didn't do that.
So just put anything, like just one. That's fine. Page bound, put like 3.
Instance size.
Depends. What's the instance size of the thing we have there? This like
Oh, the size of
model
this.
and I don't know what you have stored. Is this the name
No,
editor and
the
age?
thing that I showed you are these two lines, these two
Okay,
rows.
so yeah, it's the size of that. So it is a integer 32, so 4 plus I don't know how much is that string L
Uh,
of the editor nor the name.
no, but that doesn't matter because we're gonna serialize according to the schema. So we actually need to see how the programmer table is being done. So the field name is gonna be 7. 7. That's a lot of data. That's a lot of space. Didn't I rerun this? Maybe this is old data. But that doesn't matter at all because we can just pick the fields, the field size. So let's go to the AST and ask the field. Oh fuck. Okay, so which one? Define serializable. Thank you very much. So do we have a size? We don't have a size at this moment. We don't have a size at this moment. So we're gonna do it by hand. So the name is gonna be 7, right? Because this is varchar 7. So 7 there. The editor is gonna be 10. Okay, the editor is gonna be 10, and the integer 32 is always 4. Amount already read. I think it starts with 0, right?
Mm-hmm.
What is attribute to index? Did we use that attribute? We didn't use this. So probably this is for error messaging. Yes. So who cares? Schema and the entity name. Schema and the entity name. Do we have a schema? It is an empty schema, so we need actually to put stuff there. So let's grab this line here, and let's uncomment that. So now we have a schema, and the entity name is going to be programmer. Right. So programmer. Before we do all of that, I want to update the data because I'm pretty certain that's wrong there. So how do we do that? How do you write? This is how we write. So, oops. And it needs to be the opposite order. Write rows to disk, and these are the rows. Pretty cool. Something that I forgot is the scoping. So Racket does you need to do that. So provide build pages. Provide build pages, and that also means that we need to go to main and import that shit. Import that shit. So where is that being done? Up here. So we're gonna add another thingy, which is RacketowerDB pagination. Imagine if this works. How awesome would it be? Imagine, just imagine. Okay, so now we're gonna do this. We can actually uncomment. You can start praying, Mageta. Boom, boom. Just a build. Let's go with to the completion errors. Bad syntax. Bad syntax.
I hate these errors, man.
No, but these errors are fine. This is basically saying you're using the constructor wrong, which I guess makes
Yeah, but
sense.
I mean, it's built in general. Like the racket errors, they are
Um,
sloppy.
so type. So this is how you make a struct. You basically put in the name and the fields in positional order. The position matters. What are we doing in the other thingy? So pagination. Pagination. So we have oh, it's not a I said pages. So oh yeah, this is wrong. Right. Wait, but this is what we are doing. Right. This is what we are doing. Where are you constructing a page? Yeah, where are you
Where are we
constructing a page?
constructing a
Oh, this
page?
is where you're
On the
constructing a page.
yes.
Okay, so I was
Easy.
wrong. This was my fault, not Racket's. Um, we need to initialize. We need to initialize the pages, and this is actually just going to be what a pages require. Do we have pages actually? Pages, pages. What is pages? Oh, this is not a record. This is just a tuple. So you're just returning the list of pages and the amount already read. Well, in that particular case, it's very easy then. So we're just gonna call it pages, which is a list, and every time we do this, this is gonna be the following. This is a page that receives only two things, right? Two things. Yes, instances and indexes. And there's another gotcha here. So I don't remember how to do that. Append. Yes, that's how you do that. So boom, yeah, that. So we're gonna do something along these lines. And instead of these cones, whatever the crap is happening, we're gonna use this thing. Boom. And this is just pages. And then you are done. Next here. Oh, of course, I need to require shit. So I need to go to, oops, only in Racket. Actually, this is when you need a submodule. How the heck you grab a submodule again? Oh, like that. Okay, so and we don't want the writer. Page number unbound identifier. So
Bound identifier.
page number. Where are you using page number? Instance size. Where? What is a
Isn't
page
that
number?
are calling something
Oh,
else?
this is the
That's the
index.
loop. Yeah, that's the. Oh, I think
Uh,
you call index.
that's
Oh, you
the
see?
index. So it's index. Next zero. But of course, we need now to also grab. Uh, we need to grab. Yeah, so Racket Tower DB Uchu. Oh, it's because we are doing an only in. Okay, so build uh, NDF file name. Next, attribute to index unbound identifiers. So attribute to index in who? Where? Not here. Attributes. Oh, of course. Okay, nothing crazy. This is a dynamic language. Remember that. Uh,
Yes.
so, let's see what the heck happens. Of course,
Contract
contract
violation.
violation.
What? Given lambda roles? What the heck is happening?
Ooh, I think I kind of know what's happening actually. But this is surprising. This is not
It's
reading.
reading the
This
schema.
is reading the schema. Yes.
Yeah.
So something fundamentally got wrong, and I know how to check. Um, uh, before. Um, oh well. How are we gonna do that? How are we gonna do that? Because I need to jump this let basically, and I want to print something. I want to print something. Okay, I'm gonna cheat. So begin, boom, boom, and then print content. Uh, and these warnings, by the way, this is Racket's fault. This is NixOS's fault. This is not Racket's fault. Just to be 100% clear on that. I know the problem. I actually know the problem. I am dumb. That's the problem. Uh, this uh, this should have a flag because you're not because remember what I said before. We
Hmm.
are the default value of build NDF file name is entities. We are not in. We don't want entities at all. We want
Hmm.
data, which means that I need to pass hashtag this data that, and I'm gonna pass the symbol data. So now it should look into the other directory. Oh yeah, actually. Oh yeah.
So it is, but now what's
But this
this?
is sus. Kinda sus. How many characters do you have in here? One,
Oh,
two, three, four,
oh,
five,
count the
six,
nuls as well.
7, 8, 9. Wait, did I count it right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Am I counting this right? Is this 11 characters?
I think the dash I know how to count. Go open the file in Emacs and use the hexo mode.
Good call. Hexo
Mode.
mode.
There.
So Visual Studio Code, as far as I can tell, should be 10.
It's actually chopping the code, isn't it?
Main. No, it should chop. It should chop the code.
I think we inserted more than we could.
Because the editor is actually set to be 10 characters. So that means that we're gonna have 10 things. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, that's right.
Okay, so
I mean,
this thing is just a random byte then. This thing is just
Yeah,
a coincidence. Okay, so now we can go back to the error message.
Oh, but why is it not 0 then?
You mean the 7B here, right?
Yeah, that's 7B, right? The curly
I
basic.
believe why we have a 7B thing here. Actually, just to awareness, just to be 100% sure, I'm gonna just queue that thing and obligate it to generate again, so we can just be
You need
sure.
to delete it, right? Did you delete?
Yeah, I deleted.
Okay,
It is still the same thing, apparently. So,
yeah, but probably
data
the file is
programmer.
yeah, same thing. That's weird.
Oh, whatever. We already tested this works, so we are probably just not thinking right. Because you already tested read table from disk, I believe. Read table values from disk. Look here. If I put this here and we ask it to print, oh, of course it's gonna break because I'm stupid. There.
I was thinking, does it keep going? Like,
Yeah, just stupid. Yes, we are just not thinking right. Racket. We are just tired.
let me see here.
We're just tired, my man.
And what's that error? Like contract violation expected a possibly improper list with at least 21 pairs.
No, that means that we are sending bytes and take expects a list. That's it. That's basically the error message. So let's take a look on the place that we're doing the take. So that's where it's wrong. So take. There are two places that we are doing a take.
Oh, I see. So probably we need to bytes to a list before sending to this, right?
Wait, can you repeat that?
So I think we're just speaking the bytes, the buffer. But is the buffer a list? It is, right?
No, the buffer is like a byte stream. It's not a list of bytes.
So we need to convert to a list. That's it.
That's easy. Although I don't recall the name at all. Bytes list. Thank you very much, sir.
Easy. Easy peasy.
So now we're gonna do, yeah, that totally. I don't want to change the buffer because I think we are using the buffer more than one place. No, we are not. So who cares? Boom. Bytes. No, this is actually an arrow. And there we go. Boom. I really hate the warnings. We already know it's because of NixOS.
Okay, a list with at least 3 elements, but given a.
We have a list with only one element.
Oh, so it is right. Okay, I'm assuming a behavior because the sequence on F sharp, if the step is either greater than the bound, so that is, or if the bound is like not as much as I need, which I calculate on the other. If you put like 1, I just put 1 on the page bound and it will work. We'll back to the main.
Wait, but I'm confused. Why are we having a list of lists?
Yeah, well, you will see. Go back there.
Go back there. So I think it's the 3.
Yeah, put 1, and then now it should work.
Then you can explain to me, please.
So basically, if you look at my for the step and that it's complaining about the page bound, but the page bound is what I is what I mark to be the amount of pages necessary kept on 64, which is the amount that I can have, right? So if I can have at least that, need to have up until 64, I will iterate. But then I calculate that beforehand because I need to know how many pages I need to initialize, right? For how
Yes.
many I can initialize.
Yes.
In that case, we were trying to read more than we actually just store everything in one page.
Mm.
And we're gonna have to fix that later. So remind yourself of this.
List to vector. Thank you very much. Okay, so the error message that we got, and I apologize, Magita. I think I was paying attention to the first 2 minutes, but then I got lost because I'm tired. I apologize.
No problem.
This is a contract problem. I don't know why it's saying it like this, but this is definitely because the vector of bytes is broken, which means that we are passing a list where should be a vector, which I guess makes sense. Uh, how can we fix that? Easy. We're just gonna go here. We're gonna say list vector and like that. And the same thing needs to be applied to instances actually. So there. And maybe I need to ask Marinho if there's a very huge benefit because I think we did vectors because of performance. But I actually don't know the answer to that in numbers. I actually don't know the answer to that in numbers. Length. Okay, so something is wrong. So where are we using length? Oh, instances are not they are not a list anymore. So vector. Cool. Next error. Map expected a list, and I gave it to you something different. I gave it to you something different. Oh, that makes sense. That makes total sense. Okay, so it's actually really annoying to transform to vector in this thing. So let's actually backtrack that. Um, yes, and let's only convert the things to vectors here. And I know it looks ugly as hell, but it's gonna be ugly first before it gets pretty. As
Not
always.
pretty at all.
As always.
Not sure about the as always, but
No, the code that I did with serialization with Magita is beautiful. So,
Marinho. Right?
46. Oh fuck. Okay, so it's not that, which is kind of surprising, I think. So something that should be a vector is not a vector, and this is the perfect example. Uh, 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 what is ES? Gian. I don't know what you
Oh,
mean by
wait,
that. Yeah, he sent something on the chat in the chat.
begin page. Oh, but yeah.
Oh, event sourcing. Okay.
Yes.
Okay, I didn't get that. Okay. Wait. Oh, actually, actually. Okay, I think I understand. But okay, so the complaint is the following: expected a procedure that can be applied to arguments, and it was given this. So it's basically saying that this in the instances field of this struct, it's basically saying that this is not like a legal piece of syntax for the macro, which I don't understand because if you go to the, although it's very easy to fix, I know how to fix, but I really don't understand what's the problem because when we were doing the contracts for things, we had something called a list of, right? A list of. And I don't understand. Um, Okay, so how are we doing this for tables, for instance? Table. Oh fuck. Define serializable. Oh, we just ask if it is a hash. We just ask if it is a hash, and then we also have a list of thingy. Okay, so let's go with the easy approach, which is to convert every single thing to lists.
Oh man, this is hellish. Like,
List of, and whatever we are doing, yes, this we can just backtrack that idea. So these are instances and indexes, and that should be it.
you're
So.
getting quite expert on parentheses management.
Well, I need to be at some point. We are doing Lisp for so much time already. Okay, contract violation. We want a list of bytes, and that's
But
not what we're
what a
passing to
list
it.
of? Got a
Uh,
list of lists probably, and that's what's
yes, it's
complaining.
complaining about
But
that. And this
where?
is not a list of the internal list is also not a list of bytes, which I know why, which I definitely know why. So do you remember the function that we were using, my friends? So bytes list. If you take a look on the example, look.
Right.
That means that we need to do the other way around because these are now
Oh, right.
65, blah blah blah.
Yeah, makes sense.
But this is kind of weird because, oops, okay, my mouse. Okay, the documentation has sort of like a GUI bug that if you just scroll a little bit, it goes like you scrolled a
Bananas.
bunch. Look at the thing. So it's saying that returns a new list of bytes corresponding to the count of BSTR. That is, the length of the list is this, and the sequence of bytes is the same sequence in the result list. And the type signature is saying that this is a list of bytes. This is a list of bytes. So maybe this is just the representation visually. These are not integers because it's saying it's bytes. So I think uh, that the problem is that exactly what you said. We are given a list of lists, but a page expects only a single list of bytes. The question now is, does that make sense? And the answer is no, because you actually want a list of lists. So easy. List of, um, and then you just say list of, list of bytes. I think that's how you do that. Um, so how do you do a list of lists? How do you do a list?
Well,
Because
first of all, why is it a list of lists? I didn't get it. Which
well,
thing is a list of lists?
the
Yeah.
instances in the page.
All right. Yes, that is correct. But why
Yes,
is he complaining to be a list of lists? Like, what is
because
trying to use that?
because we are trying to be good boys and we are trying to check, like we are trying to not forbid you to create a page if whatever you're passing to us is not following these contracts.
Yeah, but what is? Oh, okay, and the thing inside is not bytes. It's the whatever, right?
No,
It's
no,
just
that's
the
the thing.
list.
That's where the error. This is precisely the point where the error message starts to go to hell.
So we
Uh,
need to map and then do the list of bytes.
no, but
The
for me, this
list
is a
then.
list of bytes. That's the thing. This is for me. This is a list of bytes, because these numbers here, as shown in the documentation, these are bytes. These are bytes. It's saying here that the return of this function, bytes to list, which is the function that we are using, it returns us a list of bytes.
But here's the question: like, do you see that there's no tick, no quote there?
There is a tick here.
No, on the second, no.
Oh, you're saying here.
Yes, maybe that's the problem.
Maybe that's the problem. I think we may
Yeah,
be
but
right.
look at the argument position first. You see?
1 second. Just let me just. Yes, yes. So how do I make this happen? Can somebody help me, please?
Well, try to map to list.
Okay, so that Stack Overflow post was useless. Okay,
Because
anyway.
I don't know what the type of the thing is. Like, is it a list of bytes or is that a just a byte? I don't know.
Is there a type of? Because maybe there is a type of. So let's see. I remember something on the lines of println um, type of. Is there a type of? Because you want to see the type, right?
Yeah,
So type of.
there
No,
is.
no, but this is third party.
Provided no turnstile.
Okay, so ask for the type Racket. How to check type in Racket? I don't want to check the type, precisely speaking.
Know
Yeah,
the type, right? How
yeah.
to know the type? Type of this much useful.
No, but this is saying basically that
Yeah.
you can do a predicate, but that's not what we don't want to apply a predicate to check if it's something. We want to know
Yeah.
what is the something
I'm not sure that is possible.
of
Maybe.
value. I don't recall if this is possible. I never did that before with Marinho, that's for sure. Okay. Um,
Racket.
so it's saying to me that it's expecting a list of bytes. So we know for sure that the problem is with the instances. Does everybody agree with that?
Oh, class off.
Class of.
Try that.
Class
Oh,
of
a racket has a describe. Actually, in Racket, it's describe.
instances. Let's see. Are you sure it's describe?
Well, the guy said it is, but maybe. Oh, that's a package.
Ooh, that's a package. Yeah, that's a package module.
Oh man,
Uh,
apparently no, there is nothing.
class of racket. No, but these are for objects. We don't care about. We're not using objects anymore. We don't have a. We're not using objects anymore. Thank God. That was an experience. Um, so I don't really know. Wait, let me go back to what we had before. I don't really know uh, what to infer then because we're gonna have to guess, right? This is definitely a list of some sort. This is definitely a list of some sort. Um, but what the heck is this? What the heck is this? I have a guess. List. Um, I think that's how you do that. List of bytes, and then you apply that to instances. I think that's how you do that. Maybe I'm wrong. F. F. So this is not a list of bytes only. So now let's try list of again. Boom. It's also F, which means that okay, it's not a list of bytes and it's not a list of bytes. So what the heck is this thing? What in the heck is this? Um, what are we doing wrong here? It's definitely because of this line, and we know that because this is the only place where you have a list of bytes. So it needs to be there. It needs to be there. So if it's not a list of bytes, and if it's not a list of lists of bytes, hmm, kinda interesting. What the split by returns? Oh wait, this is returning cones of something. Let me remember the use cases of cones because I usually use cones for tuples. Usually, I usually do that. Usually. I'm gonna finish